Prior to the year 2000, there were multiple codes across the country. You had UBC in the west, you had BOCA in the north, you had SBC, or the Southern Building Code, in the south, and then there were regions that you might not really have a building code, so MBMA, or the Metal Building Manufacturers Association, put out a code that was used in those areas. Prior to the year 2000, more or less the government got together and said, you know, we really need one code for the country. Try and get a constant factor of safety, constant way of specifying your construction, your buildings. And so in 2000, the International Building Code was formed and adopted. That code, although it says international, is only in the U.S. It doesn't, it doesn't go overseas, it doesn't go into Canada. They have their own code. The 2000 code was significant with respect to changes in all aspects, with respect to wind, seismic, and your snow loading. The main thing for wind was we went to what was called a 3-second gust. Prior to that, the wind was a sustained wind. The 3-second gust is basically the wind that's measured at an airport. That's what wind you hear on your news, where they're gathering it from. The snow load, there are some important factors. How unbalanced snow was applied was different. It virtually took snow from one roof plane, and when the wind blew it onto the other, it kind of piled it up as if it had a horizontal line from the ridge to the eave. So you had a real large amount of snow having to be designed for at the eave. And then seismically, it did follow a little bit along the lines of UBC 97, but we went to having to know different soil types. The fundamental period you needed to calculate, you had an S sub S and S sub 1, which are values that the USGS put out there for us, which was totally different than just having a zone. We went through all those changes in 2000. It did then, 3 years later, we had some tweaks to it in 2003, mainly on the snow side of things.